Okay, so in this example we have 100 deer. 30 of those deer have episodic hemorrhagic disease, and 70 are healthy. And we're going to pick 4, and we're going to let x be a random variable that denotes the number of deer with episodic hemorrhagic disease in our I guess our sample. 4, and it's a random sample, right? And what we're required to find is the expected value of x. Well, the first thing we should think about is, well, what values can x take on? So x could be one of the following values. It could be 0, it could be 1, it could be 2, it could be 3, or it could be 4. So that means that we could have 0 deer in the sample of 4, up to 4 deer in the sample of 4 that we're selecting from these 100. And in order to find the expected value then of x, what we would do is we would just take 0 times the probability that we get 0 in our sample, plus 1 times the probability we get 1 in our sample, plus 2 times the probability we get 2 in our sample, plus 3 times the probability we get 3 in our sample, plus 4 times the probability we get 4 in our sample. And we can see that the pieces that we need to calculate then are these pieces, which are just the probability distribution function of the number of deer in our sample who are sick. So let's take a look at that and see if we can generalize what those are. So let's first take a look at, well, what's the probability we get 0 deer in our sample? So that means that from the 30 with disease, we're not going to get any. So 30 choose 0, and the 70 who are healthy, we have to choose all 4 from that sample. So that's how many ways that can occur. And of course, since we're sampling randomly, this is just a uniform sample space, and so we can just count the number of ways we can get 4 healthy deer over the number of ways that we can get generally 4 deer. And so the probability that we get 0, I have this here next door on my calculator, turns out that this is about 0.23383. And so the probability that we get 1 deer in our sample, of course, then would be 30 choose 1, 70 choose 3, all over 100 choose 4. And here we get something close to 0.41880. And then from there, let's take a look at the probability we get 2 deer in our sample. Then it would be, let's see, 30 choose 2, 70 choose 2, over 100 choose 4. Well, that's about 0.2671. Or the probability we get 3 in our sample, 30 choose 3, 70 choose 1, over 100 choose 4.
If I come up with something, I'll let you know.
Yeah. 0.07248. And the probability that we get 4 deer in our sample then would be 30 choose 4, 70 choose 0, all over 100 choose 4. And that one would be 0.00699. So compiling that all together, we're going to get the probability distribution function. So these and these together are going to give us a probability distribution function. Let's go ahead and flip this on this side. So these are our x values, and here we have our probability that big X equals little x, and our x values are 0, 1, 2, 3, and 4. This was 0.23383. This is 0.41880, and this would be 0.26791, and this would be 0.07248, and here we have 0.00699. And just looking at the probability distribution function, we can kind of see that it seems to be, most likely to get a single deer in the sample, which sort of makes sense, and a little bit more likely to be on this side of 1 than on that side of 1. So we would expect a center of mass of this probability distribution function to probably be someplace between 1 and 2. So when we carry out the calculation, of course, one way to do this is just in tabular form. We would just multiply x times the probability that x is equal to x. So this column times that column, we get a 0 here. We get a 0.41880 here. We get, let's run this one, 2 times 0.26791. So 0.53582 here. 3 times 0.07248. So 0.21744. 4 times 0.00699. So it would be 0.2796. And of course, what we would do then to find the expected value is just simply to take the sum of this column. So let's go ahead and do that. 582 plus 41880. And what we get is roughly 1.200. So the expected value here is a little bit higher than 1, as we expected, somewhere in the neighborhood of 1.2 deer in our sample of 4, which are going to be suffering from episodic hemorrhagic disease. Again, this is a number meant to be an average, right? If we did this many, many times, we'd expect on average we would get 1.2 deer. Of course, you're never going to get 1.2 deer in any actual sample, but this gives us a sense of what happens on average.